Click the bell icon to get latest videos from Ekeeda.
Hello friends, let us see one more example in which we are designing a Turing machine for a regular language. We are taking sigma to be A, B or C and we are accepting all strings of even length. Let's start with the construction of the TM first. Q0 is taken as the initial state. On the first encounterance of either A, B or C, we can keep the symbol as it is, but then we have to move to the right. In that case, the length would be odd. Hence Q1 is non-final. Similarly, if we again encounter more and more symbol, we can come back and loop through to do states Q0 and Q1. Whenever we are reaching the state Q0, we can find that the number of symbols that we have skipped through is actually even. If we reach the end of the string from Q0, we can say that we have encountered even number of symbols. And hence from Q0 with blank, keeping the blank as it is, we can move to the right to the final state, let's say Q2. So we have constructed the required Turing machine. Now let us see the mathematical components and definitions of this machine. A Turing machine M contains the components Q, sigma, tau, delta, Q naught, blank symbol, and set of final states F. Over here, Q will contain Q0, Q1 and Q2. Sigma would contain symbol A, B and C. Tau would contain A, B, C as well as the blank symbol. Let's see the transition delta. Delta of Q0 with A as the input will go to Q1, keeping A as it is and moving right. Similarly, we have for B and C, completing those as well. Similarly, from state Q1 on any symbol will come back to the state Q0. After reaching Q0, if we see blank symbol, we have seen even number of symbols, so we can go to the final state Q2. For this machine, we have seen Q, sigma, tau, transition function delta. We know that Q0 is the initial state, box is the blank symbol. Over here, I am using Q2 as the final state, so F will contain Q2. Now let us try to run one string using this machine. Let us say the string is ABCA. We are using instantaneous description notation. Q0 is the initial state. Q0 on a A will go to Q1 by moving to the right. Q1 on a B will go to Q0 by moving to the right. Q0 on C will go to Q1 again by moving to the right. Q1 on A will move again to the right with state Q0. Now Q0 on a blank symbol will go to the state Q2, which is final, again moving to the right. If we move to the right, we'll get blank symbol. As we are reaching the final state Q2, we can say this particular string is accepted. Having seen a few examples in which a Turing machine is able to recognize a regular language, let's see a few examples on a Turing machine is recognizing context-free languages. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.